Of crop growth and field operations presented by Anuja APCSC, Rohini College of Engineering and Technology. The introduction of crop growth. Crop growth is a very complex phenomenon and a product of a series of complicated induction of soil, plant and weather. Crop growth simulation is a relatively recent technique that facilitate quantitative understanding of a effect of these factor and organic management factors on crop growth and productivity. These models are quantitative descriptions of a mechanism and process that result in growth of crop. The process could be psychological, physical and chemical process of a crop. Then model. A model is a set of mathematical equation describing behavior of a system. Model intimates or simulates the behavior of a real crop by predicting the growth of its component. Modeling. Modeling is based on the assumptions that any given process can be expressed in the formal mathematical statement or set of statement. Then simulation, it is the process of building model and analyzing the system. The art of building mathematical model and study their properties in reference to those the systems. Crop model, it is the simple representation of a crop. Crop simulation model, it is a simulation model that describes the process of crop growth and development as a function of weather condition, soil condition and crop management. So this is the sample example of crop model. History of crop simulation modeling. The crop simulation model were first developed to run on mainframe computers in 1960. Such models were used to estimate light interruptions of photosynthesis by crop. In 1970s, the complexity of CSM increased, giving comprehensive model requiring large quantities of input data. However, such complexities don't always lead to better model. In 1980s, the model were developed through this was often with the aid of a more complex model. Customized model also become important with the realization that user requirement often determine which should be used. Awareness and of the limitations of CSM has been increased since their introductions. Then dissipate difficulties. There is evidence that CSM can play an important role in scientific research, decision support and education. So this is the categories of crop simulating models. Then crop growth model. Crop growth model are computer software programs that can stimulate daily growth, that is biomass yield and development. Example, the crops such as the wheat, maize and potato. These models have been developed over a long period of time so that they can be now applied to support agriculture management practices. So these are the sample diagram for crop growth models. Then how do crop growth models work? Depending on soil characteristics, weather conditions and crop spices, crop models calculating the daily growth of biomass in individual plant organs, that is stem, root, leaves, grain and tubers, etc., as well as the progress of plant development from sowing to maturity. In addition, crop model account for important progress into soil, that is water and nitrogen availability, in order to stimulate crop growth during a whole growing season. So this is the sample diagram for crop growth model. The major and popular crop simulation models are DSS-80, Decision Support System for Agrotechnology Transfer, then AquaCrop, InfoCrop and APSIM, that is Agriculture Production System Simulator. So this is the sample example for crop growth modeling. The impact of modeling in agriculture. The following impacts are evaluation of optimum management for culture practice in crop production, then evaluate weather risk via weather forecasting, then proper crop surveillance with respect to pests disease and deficiency and excess of nutrient, then yield prediction and forecasting. There are these are resources are converting some tools that is solve various practical problems in agriculture to prepare adaptation strategies to minimize the negative impact of climate change, identification of precise reason for yield gap at farmer field, then forecasting crop yield, then evaluating cultivator stability under long term weather condition. Uses of crop system management to evaluate optimum management protection for cultural practice. Seed rate, that is optimum seed rate, can be found out with the help of this model. Irrigation, optimum amount of time of applications can be stimulated. Fertilizer, optimum amount of fertilizer and time of application of the fertilizer can be stimulated. Then yield gap analysis, the potential yield can be stimulated using these models, and the difference between potential yield and actual yield is the yield gap. Then yield prediction and forecasting, evaluation of climate change, useful for solving various practical problem in agriculture. Then resource conserving tools can be used in predicting farming studies. Then every very effective tool for predicting possible impact of climatic change on crop growth and yield, help in adaptation strategies by which the negative impact due to climatic change can be minimized. Then applications of crop model based on understanding of plant, soil, weather and management interaction, predict crop growth, yield, timing, then optimize management using climate prediction, diagnostics yield gap, actual versus potential, optimize irrigation management, greenhouse climate control, quality pest damage, precision farming, climate change effect on crop productions, and can be used to perform what if experiment on the computer to optimize the management. Thank you.